The projectile equation is used to calculate the launch of an object from one height to another height. For example, if a Redmond High School student wanted to catapult something at Eastlake, they could plug in all the necessary variables and figure out exactly how to do it. The equation they would use is delta y, the change in height, equals tan of theta, the launch angle, times delta x, the launch distance, minus g, the force of gravity, divided by 2 v initial squared, the initial velocity, times cosine squared of theta, times delta x squared.
You can only use the projectile equation if the height of the takeoff versus the landing is different, like a 5-foot kid shooting on an 8-foot basket. Causing motion. In physics terms, what can a push do to an object? You can change the direction of an object with a push.
For example, when a professional soccer player dribbles a ball, she exerts a push force on the ball to change its direction and increase its velocity. As Galileo said, you don't need a force to move, you need a force to accelerate. This can include increasing or decreasing velocity or changing the direction of your velocity. When there is no push, the acceleration is 0.
Oh no, Steve Carell needs help. If the supersonic sprinter needs to save Steve, he must figure out 5 things. V initial, which is initial velocity, Vf, which is final velocity, a, which equals acceleration, delta x, which is displacement, and delta t, which is the change in time. Now, he only needs to find out 3 of those things if he knows how to use the right equations. For example, if he uses delta x equals v initial times delta t plus half of acceleration delta t squared, he doesn't need v final. If he doesn't want to find acceleration, then he can use delta x equals half of v initial plus v final times delta t. If he doesn't want to find v initial, there's an equation for that one too. Delta x equals vf delta t minus half of acceleration times delta t squared. If he uses vf equals v initial plus acceleration times delta t, then he doesn't need to find delta x. And last but not least, if he doesn't want to find delta t, he can use vf squared equals v initial squared plus 2 acceleration times delta x. Any of these equations are great, but if he wants to save Steve, he better hurry up. Now that the supersonic sprinter has saved him, he's happy. Thank you, physics, for being a part of all of our lives and making every day, projectile and motion-wise, easier.
Say goodbye to Mary and Sarah.
3,
Oh.
2, 1, go!
Wait, they might have made it.